Good afternoon and welcome to the IATA Digital Cargo webinars. We'll be starting this session shortly. Thank you. Good afternoon. This session will start shortly. We're just waiting for a few more attendees to join. Good afternoon and welcome to the IATA Digital Cargo webinars. Thank you very much to join this session. This is our sixth session. We've had five so far. We have one more after this next week on Tuesday. This session is going to be about the European Federated Project. And I'm delighted to have a panel with me who will introduce in a second. Just so that we're all aware, you all have been put on mute automatically. If you have any questions or remarks, please put them in the Q&A, and then we can get to those at the right time. Also, this webinar is being recorded, so if you're okay with that, please stay. If not, then it's probably a good time to leave, but I don't think it will be an issue for you. So with that, I would like to introduce my panel, and please, panelists, join me on the stage here. Roland, welcome. Okay, very good. We're all here. These good people here have joined me from the project. We actually work together on a very regular basis, and so we're all colleagues in the same way that most of you on the webinar, I've noticed, seen on the names that we work together. I would like to perhaps ask the panel to introduce themselves, and I'll start with Roland. Roland, can you introduce yourself, please?
Good afternoon, ladies and gentlemen. Thank you so much, Henk. A short introduction. I am a policy coordinator at the Dutch Ministry of Infrastructure and Water Management. You can also read it as Ministry of Transport. And my prime occupancy is to take care of the Federated Project, in which I act as the project coordinator. So what I have to do is see whether you behave properly and whether we can bring about our messages clear and effectively. Thank you.
Thank you very much, Roland. Let's go to Michael Rens. Michael. You're on mute, Michael, still.
Too many buttons to push.
There you go.
To get unmuted.
You got it.
Well, anyway, so my name is Michael. You can see that on the screen. I am working for the Swedish Maritime Administration, and we are a part of the Ministry of Transport, so to say. So I'm also a bit in the transport sector, but more maritime focused. In the project, I am the activity leader for the pilots or the living labs, and trying to coordinate them. So that's me.
Thank you, Michael. And then Mitchell.
Thank you, Henk. My name is Mitchell Oud. I'm employed by the Customs Administration of the Netherlands as a policy advisor. And within the Federated Project, I've been happy to chair a great group of people in the architecture board in developing the Federated Architecture the last period.
Thank you, Mitchell. And myself, I'm Henk Mulder. I'm the head of digital cargo at the International Air Transport Association. And so here you can see it here. We have aviation, we have maritime, we have government, we have customs. It doesn't get better. In this particular session, I'm here as a role as the chair of the semantic modeling group. So changing hats here, and I look forward to sharing all of these things with you here. The first speaker is going to be Roland, and so Roland, let me give you the control of the screen. Right, I'm making you presenter now, and then you can share your screen and start your session. So I will leave myself the camera off and leave the floor to you. Thank you, Roland.
Thank you so much, Henk. Again, good afternoon, ladies and gentlemen. A pleasure to participate in this event, also to have Beata on board of this European activity. I just shortly introduced myself, but by introducing myself, I forgot one thing, which is very important, that this Federated Project is an EU Connecting Europe Facility Framework subsidized project. It's considered to be a study, and it is considered to be in coordination and close cooperation with the European Commission in executing its policies. So we are about a study, putting our work ahead and in close cooperation with the European Commission, see whether we can develop a policy on this, but also to see how it could work in practice. Now, by not further ado about this perspective, apart from where is all this European policy about? And actually, that's why I changed the pink project colors into the blue and yellow colors of the European Union. The issue which is at stake for the European Commission and the European policies is digitalization as one of the major pillars for the future shaping of Europe and sustainability agenda, and many issues relate to sharing data and sharing data in the development of a policy which relate towards more technology independent, more technology sovereignty for the European partners, for the European countries, EU countries. And that is one of the principal issues. And in that framework, there's either speaking about a digital single market we would like to establish, in competition or in collaboration with the US market, which relates to the more or less individualistic perspective of platform economies, and the Chinese policies, which relate more or less, well, it's difficult to say, but a more concerted perspective of a whole continent on seeing how to further explore their activities on different continents in the world. One of the major issues in developing the sharing of data within the framework of Europe is to be building on what has been developed in the digital transport and logistics forum within the European Union, which is called in the acronym the DTLF, which says anything we want to go in future relate to developing data sharing as a commodity under the conditions of plug and play, a federation. So it should be in a decentralized form. There should be no centralized power. It should be technological independent services. And of course, safety, security, and trust are major ingredients. Now, to further elaborate a bit on the EU Federated Project, we have to develop future-proof data infrastructure. We are covering 15 partners, 7 from the public and 8 from the private. We are covering 8 10T corridors. For those people who are not located in Europe, corridors is the way how we in Europe think that we can cross the borders by having European subsidy in order to make cross-bordering transport in this perspective easier to go. We're doing covering 4 of these building blocks I've mentioned before, and we are developing our policy, have started to develop our execution of our project in the period 2019-2023. So by the end of 2023, we have to be, we are closing the project. Maybe there will be a follow-up, you never know, depends on the collaboration, the outcome. But in the whole sense, we're covering many parts of Europe. We're always eager to cover many more areas. Instead of making it blue, we're going to turn it into a pink perspective. We are turning it, we're working on that. But you also can face it from the perspective that we are focusing on realization of interoperability. And the interoperability relates to three items, which is interoperability in legal terms, which is more or less the essence of the European Commission or the European Union in developing legal framework. That is not part of our project. We are actually focusing, if you see it, the interoperability of languages, technical issues, and how to allow cooperation between organizations. And one of the major problems we are feeling confronted with, and which communicates very well in forming a kind of effective partnership, is actually our more or less struggle against the dominance of IT platforms. But if we allow that to happen, could dominate and disrupt our logistic chain in such a sense that we are not building a Europe for the future, but we are going to get a fragmented Europe. Now, actually, I'm identifying 4 problems, and in these 4 problems, I have to relate to the fact that although within the Federated Project we are not developing a new legal code, we actually have to perceive the Federated Project from a perspective on how to develop for the future a platform of networks relating to enhancing supply chain visibility and optimization of assets and infrastructure use, in that sense that new services can arrive. And at the moment, that is difficult to get to, because in the interaction between different peoples, which is the business processes, there is not very much, in every sense of the word, an interoperability, an equal playing field. And to get an equal playing field, we have to perceive that what is going on is some major cultural features, some different changes that have to be confronted by many different stakeholders, and that makes work for like a small and medium-sized company very difficult to cope, how to get from their micro environment into a data environment by taking hold of the perspective that instead of having physical transactions, they have to do business with multi-model platforms, that data spaces are emerging, that we're working with issues like digital twins, that we're getting to an economy which is not push-based, but which is pull-based, and where global tendencies very much impact on the local issues. That relates to developing problems. And in developing our work, if we take the position from a judge, we have many different laws in place that help developing an equal level playing field. And the basis of these laws, and I mentioned some, but there's not sufficient legal framework at the moment in place, we're developing a kind of framework architecture perspective based on some legal principles in order to create, in technical sense, a kind of law perspective which allows an equal playing field. And the principles behind there is equality, justice, and freedom. You have to be able, in order to have a data sharing perspective, a level playing field based on a freedom perspective. And in order to help them, and in order to help the European Commission in getting this freedom available for data sharing in a federated way, our product focus on actually three very important issues, which is semantics, and Henk will further elaborate on it, which is technology, our architecture perspective, and Mitchell will go further into it. And it's also organizational issues, how to all cooperate with one another. And Michael will elaborate on some living labs, some experiments where we use the semantics and the technology in order to make companies collaborate and show that it can work, yes or no. Now, the basic principle of what we are designing is not an ecosystem, but it is a web with linkages to all kinds of ecosystems in the logistic areas. You can call it a kind of architecture of intelligence to have a very intellectual kind of wording to what we are developing. Henk will just call it an Internet of Logistics, but that is the next phase. Anyway, if I'm going to the next one, we have made a kind of mind map. What are we developing? Based on the processes, we're developing a kind of major issues, and Mitchell will elaborate on, where we develop a kind of web infrastructure that orders, functions, regulates, sets the scene on how to get a decent data sharing based on a language that everybody understands, that the data you need are findable, that everybody can access to, and that is safe and secure, based on which you have an identity. And that is actually also in future will be the basis of what we will be presenting and what will be possibly the governance of a future perspective, a set of arrangement as an outcome of the Federated Project. Now, what do you get out of it? I'm now taking a bit of the initiative to introduce Michael Renzina later. We have the input of the different logistic chain operators, and within logistic chain operators, actually we include authorities. We have many different platforms. We have definitely opportunities to share data. They have to be in resonance with one another, and the outcome will be that you can do different measuring on CO2, that you can have ATI expenditures, expectations. You can better know in advance when is a truck or when is a train arriving, instead of 50 minutes before it arrives at the terminal. You possibly can also know it 3 hours in advance, depends of course on the distance. You get more smart mobility opportunities. There's a wide range of opportunities you can gain on. Well, what is the package? If we turn it in a box, we provide in the end of the product you with a box. The box is an information box that is necessary and is available for everybody. And if you open the box, you are allowed to do borderless communication under your own control. And the control relates to 100% safe and secure. You get data on demand, you get open access to it. You can easily find the partners. It's 100% federated, and it's 100% data sovereignty. So you will be your own master. But here is a short summary of it all. It starts with readable data. It should be accessible and available through your own system. You make it yourself known through an index and a service register. You have a search information like a Google search where you find everything you need. You can access it and you can do business based on a set of arrangements, which is a general set of arrangements, and you can specify it for your own cases. That is actually what we have on offer. What is actually very, very important, because we are developing a policy and an execution of the policy in the framework where there is a multitude of stakeholders, logistic chain operators. Some are very knowledgeable. Many are still not very much into the area of data and data sharing. We have to enhance our operational brain power, and it needs to be done in such a way that is covered by a decent EU legislation, not too much, but not a little, and it needs to guarantee that there is no centralized power and that we can do it on a full basis. Well, thank you so much for your attention. We are also in the process of developing a toolbox, but I'm sure Mitchell will tell about it. But the first 4 issues of this toolbox is about semantics, and one of our superior specialists on semantics on how to do it will be the next speaker, and that is Henk Mulder. Thank you so much for your attention.
Thank you very much, Roland. I have questions myself for you, but I'm going to hold back, and I just want to remind everyone else that they can all ask questions now, okay, if they want. There is the facility in the there should be a Q&A box somewhere, and while that's going on, I am looking for something else, which I can't quite find right now. But yes, okay, very good. With that, then I thought actually it was Mitchell, the next speaker. So, Mitchell, are you ready to present? You are, very good. Let me just give you the control of the screen. Okay, you should be able to get it now. And so we're moving from the high-level project and the European perspective to the architecture side of things. So we're going sort of slowly into the technical side of things. So Mitchell, the screen is yours, and the floor is yours, and I will leave my camera off now. Thank you.
Okay, thank you, Henk. Yeah, so as I said in the introduction, we are working within the architecture group to create the architecture for Federated. For today in my presentation, I would like to mention our approach, the building blocks and elements of building, the concept of linked data, show you the high-level architecture and its implementation variants, and then say something about the relation between the architecture, the semantic model, and the interfaces between them, and have a short introduction into the next steps. So as Roland just showed, we started with the DTLF building blocks on the left-hand side, so plug and play, technology independent services, trusted and secure, and federation. So what we basically did was translate these building blocks into quite extensive sets of leading principles, and these leading principles can, for example, be use open standards, data at the source, making sure that access to data is provided by the data holder, things like that. These have been translated into the architecture for Federated itself, and is also a baseline for the Living Labs, but I'm sure Michael will address that. So what you see here is the mind map Roland just mentioned. And I think this is one of the basic or fundamental parts of the Federated concept. And I would like to talk you through these aspects or these categorizations. In the left-hand top corner, we have the language, and that is something that is one of the basic building blocks. We need to make sure that we understand each other. We have all kinds of standards within Europe, but also within different modalities. And we need to make sure that if we address cargo from a rail perspective, it's also a cargo from an air or a sea perspective. So we need to have a common understanding or a description of what we mean with a specific label, but also we need to have a standard in which we can use to translate our own maybe proprietary models to the open model that we use within Federated. Of course, supported by open standards, and we should have ways to implement these, and that's something we're working on as well, and I'll come back to that when we later in the presentation. So next to that we have the processes, and let's say that that is a basis of creating events. So we have all these kinds of business services, relations between different organizations, or organizations from the business side to the government side. And within these transactions, we actually create events. I'll address that some more, but basically these are the events that tie all the actions within the logistical chain together. Then addressing searchability, which is one of the foundational building blocks within the architecture. As Roland said, we have the service registry, and the service registry should be translated as some sort of the yellow pages. So what data holder can provide what information in what process. So that's basically a component that enables every participant within the network to broadcast their services. Next to that, we have an index, and that index will contain events, so process transactions related to cargo or shipments or movements that provide a specific reference to the original information. So we can use events to find object information, for example, about cargo. And then, of course, we need to search that, and for that we have a search functionality. Just to elaborate some more on the index we're now thinking will be a publish-subscribe mechanism. So the availability of information will not be broadcast to the entire network, but will be broadcast to those that have subscribed to that specific information. And of course, you need accessibility and rules for access to that specific information, and that is regulated through the accessibility. So we'll need to make sure that data is kept at the data holder side, and the data holder will decide what parties can actually request the information. Yeah, all the power will be at the data holder side. And of course, these need to be compliant with policies in place. So then we have the identity. Of course, also very important. We need to make sure that every participant in the network is who he says he is, because it will be a basis on which data will be provided by the data holder. So we will need at least identity brokers that can communicate with each other and identify specific parties in the network. And the authentication, as said before, will be handled by the data holder, so the party that is supplying the data. And from a more technical point of view, we have data sharing solutions, logging and audit trails, standardized APIs, or at least conceptualized APIs, identity tokens and certificates, and of course end-to-end security relating to the secure and trusted from the DT-led building block. So as I just said, what you can see here in the bottom, we have the physical world, and the physical world can be expressed in digital twins. So a truck can be a digital twin, but also a container can be a digital twin, or even a package can be a digital twin. And these digital twins actually move based on transactions from within the organizational network. So that's the top part. So when an organization has an interaction with another organization or moves the truck from A to B, then an event is created, and that event is actually tying all digital twins together. And these digital twins can be locations, of course, but also objects. So maybe a port or a ship or a port. If you move a shipment from port A to port B, you have an interaction between two digital twins and having an influence on a third. So that's basically the concept. I'm going to skip by this one somewhat fast. I think I've told something about the digital twins and the objects, tying these together from events, and then business transactions actually create these events. And I work for Dutch Customs, and of course we see here the customs item, and that can be a permit or a declaration for import or export that also triggers an event on digital twins. So here we have the choreography of the data model. So we have the semantic model in the middle, the business services and business interactions, the events and the digital twins. And these can be expressed in derived concepts, and those can be, of course, an itinerary or a route or a movement from A to B. And what we're actually doing is conceptualizing these derived concepts and developing tooling to create your own concepts based on the conceptual concept that is part of the semantics. And then we have the federated shape graph, and that actually constrains the semantic model in the middle, and these can be formats, but also minimum sets of data, etc. And we're now envisioning this will all be supported by the semantic web stack, which is in the top left corner from the WC3, which is of course an open standard that can be used by any party. So just some short things about linked data. I think Roland said that very well. We're not trying to create an ecosystem or a platform. We're actually creating a web between platforms or ecosystems, and that's actually expressed in this sheet. What we see here is that we have company Y that is transporting a container through company Z to a specific port. And what we can do then from within the federated concept is search within the events and then address that specific ecosystem or platform through a unique URI that will provide us the detailed information about that transaction. And what we see here is actually the events or the transactions that can occur in a use case like this. So moving on to the conceptual architecture. On the left hand side we have the data holder, on the right hand side we have an organization which will be the data user. On the top part we have the identity brokers that vouch for the identity of the participants, and in between we have interfaces that can find specific information, can make sure that we can broadcast our identity that we have obtained through the identity broker, and we can exchange event information. On the bottom we have the model management, which is a reference to the semantic model, so we all talk the same language. And then we have the access policies, and this is something I would like to emphasize. The access policies also relate to the model management, which basically means that an access policy can be expressed from within the semantic model, which creates fine-grained or fine-grained granularity for access to the specific information that is requested by the data user. So those are very highly dependent from each other. This is one of the implementation variants which we are now researching in the Netherlands, which will have a local index which will be a node in the network, and these nodes communicate with each other. Every participant in the network will have his own node, his or her own node, and these will synchronize. So for now, in our proof of concept from within the Netherlands, we're using blockchain technology, but of course there are all kinds of other peer-to-peer technologies possible, or federated services possible. So yeah, that's not a technology choice per se, but it should be a federated concept with indexes that synchronize their specific information and references to the source data. The rest of the pattern actually stays the same. And then we have another implementation variant, which is the multiple users that integrate one local index. That's of course also possible if you have a specific geographic location, or maybe a port community that will create a shared index for the companies around or on that geographical area. Yeah, and the rest of the pattern of course stays the same. And this is the last one, which is explaining the services register, which basically works at the same way. You have a service register or more service registers that can communicate with each other. Those can be part of the index, of course, or the solution that's serving the index, so to say. And these can be used to broadcast your data availability to the network. So as a last sheet regarding the architecture, I think this is a very important concept. The architecture components and the semantic model are highly related to each other, and they're supported by the creation of interfaces and basically a way of working with the data and with the services that are available through the network. This is my last sheet. So what we're now doing is validating the elements of building through the living labs. I'm quite sure that Michael will elaborate on that. And that can be one element of building or several elements of building within the living lab. But what we want to do, of course, and I think Roland mentioned that, is we would like to test specific corridors or trade lanes. So we would like to expand the living labs in interoperability between several living labs, in testing several technologies, but these technologies should adhere to the overall concept. So that's something we will do in the next steps. And then based on the lessons learned, we would like to refine the architecture, of course. So that's basically what I wanted to share with you. Thank you for your attention.
Thank you very much, Mitchell. As we have seen, so Roland, he painted the picture really at the business and government level within the EU and the challenges we have there. Then we now looked at the architecture, which is something that certainly, I think at this webinar, many people are sort of familiar with these sort of things. And we're sort of going more abstract now. I will now be presenting some work we've done on semantics. So let me take the screen back. Let me see if I can manage to do that myself. Right, very good. So thank you very much, Mitchell. What I'd like to do now really is have a look at semantics. We created something that we call the Semantic Modeling Group within the Federated Project. And we have about 20 or so permanent members in that. And then we have a whole group of people that join on and off depending on the challenges that we have. Let's sort of dive straight into it, and you'll see coming from architecture, you'll see why this matters and how this perhaps is one of the really central themes of the work that we're doing. So I need to try and change my slide. There you go. First, a conceptual point, perhaps. Something that many of us are familiar with is how we currently design our systems. And really, if you look at this picture on the right here, which is something that could the others mute if they're not speaking? What you can see here is that if you look back, now you have to go back to the sort of mainframe era, where the entire objective of systems was to produce documents, and we were using code to do so. Since then, of course, we've all grown up in an environment where we had abstracted the data models from the code. So we were separating the data from the code and could still use that to produce documentation. Where this is now leading to is an environment where the data the models themselves are abstracted and into something that we refer to as ontologies. And this is a very, very important and powerful development, because these ontologies, we can still use them to create data models, and they will still interact with the code. That doesn't change, okay? So we can still do the work we have already done. But what's interesting is that in addition to being able to produce documents, whatever form or shape they might be, we can also start looking at knowledge directly through these ontologies. And of course, in 2021, where everybody is interested and concerned or actively busy with artificial intelligence, the concept of knowledge is directly related to that. In fact, for those of you that are working in artificial intelligence, a lot of the work that's being done today is based on machine learning, where you give a lot of data to an algorithm that is capable of extracting conclusions and knowledge about the data that is there, and then you can use that to make some inferences and make decisions. In fact, what these machine learning algorithms do is they recover the ontologies that are embedded in the data. And that is one way of doing it. The earlier attempts at artificial intelligence actually started with ontologies. They didn't start with machine learning. And so the two are coming together. So what we're doing here has two powerful benefits. One is that we get ready for the AI era. And secondly, we're able to generate whatever data models we need in whichever environment. And you will see that this is something that is very relevant in the work that we do. Just a word about the Federated Semantic Modeling Group. The objective here, as it says on the screen, is to integrate existing model standards and ontologies such that the Federated Semantic Model acts as a common and uniting model, and so that it stands in between. And this goes back very much to the introduction by Roland, where we are in an environment where there's lots of transport companies out there, lots of logistics companies, government is there, of course, customs is there, all of the entities involved already have their own models. And so what we need is not to replace that. That will never happen. It wouldn't be realistic. You can't have single solutions anymore, but you can try to make them speak to each other. And that's why we need that semantic model in the middle. And so what we have done in terms of work as a group is that we analyzed a representative set of data models, which is essentially all the models that are out there, including, in our case, the aviation data models, such as Cargo XML and One Record, but also from the road, for example, with the CMR or the ECMR. We brought in some maritime standards and rail standards. And so we have a starting point and understanding of what those models are. We then developed the semantic model, which you will see in a bit more detail, and made sure that we could actually map those back to those original data models. And now we're in the process of testing this through living labs, and Michael will speak about that a bit more. Here's a picture you've just seen because Mitchell showed it to us, but a little bit more detail here. So here, what you can see here is on the right side are things that we're very familiar with, the fact that we provide business services. They will be provided by either natural or legal entities, persons. There are customs items. And on the left, we have the whole digital twin story, digital twins of products, of the goods, of the equipment, of the transport means. And then we have a special category, which is around where this happens, and that is the physical infrastructure, nodes, hubs, and places. In our case, there could be airports, there could be warehouses, there could be transshipment places, and then all of this is connected through events. For example, you might agree on, or you might sign a contract for the movement of goods, in which case you have a business service and an event, and that will link together probably the transport means, the goods, and a node and a hub and a place. So these things all link together, and this is the basis of our semantic model. We've actually split it into 5 modules, as you can see on the left here, because the actual semantic model itself gets to be quite unwieldy fairly quickly, because it is a model, and so we have already put some structure in that. Now, let's sort of dive a little bit into the detail here, just to give you a sense of what it is we have actually developed. So I mentioned that we have these 5 modules, and you see them here, and you recognize, you know, there's events, digital twins, business services, infrastructure, and we've added another one called classifications. This is everything to do with code lists, for example, customs code lists or dangerous good code lists and things like that. And so if you were to zoom in here, you would see how within that group, all the different concepts relate. So if I just zoom in one step further, here we can see, for example, the digital twins of things like equipment, physical objects, packages, and you can see how they relate. Okay, so you can see that a transport means is a physical object, and an airplane is a transport means, or a vessel is a transport means. And similarly, if you look on the other side, for example, you can look at a commercial product that is a product and that is a physical object. And so you can see that the way that you sort of navigate these semantic models actually is really easy. And it has to be easy, it has to be obvious, because the whole point of a semantic model is to represent the world that we operate in. This may not be obvious to a school teacher or to a nurse, but to people in the logistics and transport sector, all the terms that you see in the semantic model are the terms that we use on a daily basis in our vocabulary. Okay, we've just put it down. And okay, and sometimes, you know, we may say, okay, we call something a transport means. Now, you may have used another term for that, but it doesn't matter. I think you will understand that in this case, an airplane is a transport means. Okay, so you may have used slightly different words for that, but you recognize immediately from the relationships what it represents in your environment. So we go a bit deeper still. You end up with code. Okay, somewhere along the line, you have to end up with code. And in a sense, it's good to see that, because it shows you that this is real. This is not just vaporware. This is not PowerPointware where you show bubbles and more bubbles. This is actually something that we have implemented. And so, for example, we're looking at an event here from the event group, and this will be an arrival event. And you can see here in the comment that an arrival event is an association between a digital twin type, a transport means, and a location. Okay, well, that makes sense, doesn't it? Perhaps the transport means may be a train which arrives at a station where it's going to be offloading its freight. Well, this is the sort of detail that we go down to. Before I move on, you may be wondering then, okay, is that it? You know, and then how about the details that we have in our environment? For example, in the air sector, which I know well, we may have the concept of a ULD, which is a container, and the ULD will have an identification. It will have a status. It may be moving from A to B, and there's a lot more to. It may have a certain what we call form factor or shape, contour. In fact, is the term we use. And these are really important things if you actually want to put it in an airplane, because it has to fit. Those sort of details, they have no place to be in the federated semantic model. They are specific air sector semantics, okay, which we cover in the one record model. And similarly, anything to that's very specific, say to maritime transport, they have their own models. And so the point of federated, as we started off saying, is to link it all together, is to have something that links it all together. But as such, the actual concepts remain relatively high level, which is exactly how we want it to be. Now, having got this, let me just back up. You can see here some terms there. There's the term RDF. You can see it at the very top on the left there. RDF is a data format that is used for specifying these semantic models, or these ontologies, as we refer them to. Now, what can you do with that? There's a lot you can do with it. And coming back to the very first slide that I showed you, we're moving away from embedding everything into fixed data models. We one level up, a more abstraction using the ontology concept that allows us to create data models. So we need to operate at a level. And so what can you do with that? Well, to stay with the example I just gave, we have a federated ontology or a semantic model which explains the general concepts around freight and freight movements and logistics. And then we have the specific air sector, rail sector ontologies that we can align with that. In fact, align is a technical term in ontologies for interfacing or linking or connecting, okay? So we're aligning the ontologies. So that's really powerful. It means that you can start sort of creating a whole world semantics by putting all of the different ontologies together, all of the dialects, I would almost call it. You put them all together into a single language. You can, of course, map them to data models, which is very powerful. It's necessary. You have to maybe map it to XML or to JSON or whatever format that your world uses, that your system uses. You can also generate data models from the ontologies. And we'll look at some examples in a minute. We can generate APIs directly from the ontologies. We can start using graph technologies like knowledge graphs, which is something that you'll be hearing a lot about in the years to come, because slowly but surely the world is transforming its intelligence into graphs. And you can query and reason with them, and now you're in the AI world. So but we'll look at all of those. We'll have a dig in. So firstly, we can align ontologies. And actually, we had a really nice opportunity in a federated project, because the European Union Agency for Railways created a complete ontology for rail. And so they have models that describe exactly how the European railway networks are constructed, how they fit together, how they all link up, what the status is of these various things, what the rolling stock is like that's on top, what is the operational status, what are the challenges, the issues. And on top of having the ontology, they also have the data. And so they can actually, they're using graph technology to query that. So they can write queries like, okay, what's the traffic situation in Brussels like? What are the issues? Or where is my freight? These are the sort of questions you can just literally type in and you get an answer. And so we used that specialized rail area and linked it to the federated semantic model, which is the sort of the neutral one in the middle. And we had really very few challenges to do that. It kind of works. They use their language, we use ours, but we're talking about the same thing. And so we can actually align that. So that was a nice test, and we will see that we will do that for every mode of transport within the EU. Another experiment or test that we did was mapping data models. And so, for example, there's the trade lens system or solution that has its own data model. And we were interested in seeing, as part of one of the living labs, on could we actually map a data model to our ontology, to our semantic model, which is not the same as mapping another ontology. I don't know if you can see the difference. One is you map the semantics, you map the language and the construct, and the other is one level deeper. You actually map the data model that is very specific and very rigid in a sense. And so we did that experiment, and we were using some standard technologies. I think we're using GraphDB for that, which has facilities that really help you in start interacting and integrating and importing the model. So that's another nice one. You can also generate data models. And I'm showing here an example from the One Record environment, which is also an ontology, which actually follows very closely the work that's being done with the federated. And there's a lot of interaction in that. And so what you can see here is that we have an ontology. In this case, I'm looking at the sort of a branch that looks at CO2 calculation methods. And we can use it to generate a JSON file. In this case, it's JSON LD file. LD stands for linked data, which goes back to the examples that Mitchell gave. And it gets generated directly. We don't have to maintain this or write it or update it. We update the ontology, and then it automatically generates a new file here, which you can use. You can exchange that. Even if you don't know anything about ontologies, you can use this particular document to start reporting on CO2 calculation, for example. We can also generate APIs. And again, I use the same example. We have the one record ontology, and that actually generates without any sort of interim steps or work directly in API. And for those of you that know anything about APIs, you'll recognize that this is a Swagger document. Swagger essentially is sort of a very elaborate way of showing the API. It shows you what the endpoints are, where you would actually present the data. And it also includes some examples of how that data has to be formatted in order for it to be consumable by the API. And again, this is all generated directly from the ontology. And we actually use something that's called an object triple mapper tool to do that. So again, you know, it sort of limits the work. We only have to worry about our semantic model, about the ontology, and the technology does the rest. Then there is the notion of knowledge graphs that I mentioned before. Here you can see the this is an example again of the one record ontology, because I had it in front of me, so it was easy. But this is what these graphs look like, and as you can see, they're not trees, right? It's not like you have different categories that link to different categories. This is actually all of the different concepts are linked together. It's more of a web of concepts and a web of knowledge than it is anything else. And so once you have that, you understand the relationships. Each of these bubbles is connected by a meaningful relationship. Like, for example, this bubble is a child of that bubble, or this bubble is of a type of another bubble. Okay, so there's lots of information that's behind that. And that then leads us to querying and reasoning. And what you see here is a screenshot from a tool that's being developed by TNO, which is the Dutch research organization, which is part of the Federated Project. And so they have the complete federated ontology implemented, and then they can write queries that will actually extract from that very complex network that I just showed you, just the elements that are relevant. For example, in this case, they're looking for a query. They want to understand more about cargo and the different types and what you can do with that. And so they run the query on the overall network, and it comes out with just that specific component there. And that's very much how, you know, now and going forward, we'll interact with these models. We can actually create and extract the relationships of these semantics on the fly, and then use that, of course, in an implementation, and then start exchanging data on that basis. It's a very powerful technologies, and it's sort of all leading us down the path of artificial intelligence, and being able to start looking at the European transport infrastructure as a network that we can interact with, that we can query, that we can operate. Couple of last slides, I think they are really just to say, what does it actually mean in practice, right? Because if by now I've lost you, that wouldn't surprise me. Some of these discussions around ontology semantic models do go a little bit into conceptual spheres, and you may or may not be familiar with that. And so if we look at the practical use of this, if, for example, or you know, we look at the example on the left, we have an ECMR, which is the bill of lading, if you want, for road, or the way bill for road. We have that in an XML format. And we actually would like to extract the information and put it onto an hour bill, so we can take the freight from the truck and put it into an airplane. So we need an e-hour bill. And so the way this would work is that we would convert the XML into RDF. RDF is the format we use for the semantic model. We then, you can't see it very easily here, but we then have a query database that allows us to sort of update some data in the semantic model based on the information in the ECMR. We can then sort of do another query and extract that and put it into a JSON.d format in order to generate the e-hour bill. And so this is what we refer to as a round trip. You start with one format, you go to another, and you go via the semantic model, so via the ontology. Now, what I often explain when I show this is that you may or may not be interested in all of this fancy semantic modeling technology. It's fascinating, it's interesting, but it may not be your thing. You may be working on the business side of transport, right? And you only really want to touch the first part of it, which is understanding how, for example, your ECMR, what that looks like, or what your e-hour looks like, without having to worry about the rest. And so that's fine. You can do that and leave the rest to the experts, leave the rest to the people that you know, the academics or the engineers in your company or of your supplier, and they can deal with that stuff. So you don't have to worry about all of the details that I've just talked to you about. As long as you know that you can use this approach to go from whatever your environment is to whatever environment another mode has that you may be interacting with. And just to sort of take that one step further, as we know, we have a history in transport of having lots of data models. We have the World Customs Organization has a model, UNCFACT has their model, IATA has multiple models, TradeLens has a model, ERA has a model, and in fact, probably if you were counting, you probably find yourself with hundreds of models very quickly. And one of the neat things is that in the old-fashioned way, if you want the old way where we didn't use semantic models, if you wanted to exchange data between, for example, UNCFACT and IATA, you would have to start looking at how does their data model map to ours, right? And we would then have to agree on those mappings and probably write some software to be able to actually transfer data between one and the other. And if I wanted to do the same thing, for example, between the ERA and WCO, right, the railways and WCO, I would have to do the same thing. I would have to start doing mapping exercises, and I would have to then start writing special software to do the interactions. And if you do the maths, what you'll see is that very quickly, if you have many models, the number of interfaces, the number of mappings goes up exponentially to the point where it's not practical. Excuse me, which is one reason why it hasn't happened, right? It's one reason why a lot of these organizations haven't actually done effective mapping between their work. Now, using this semantic model approach, where we have the federated model in between, as long as each of these, what we refer to as syntactic models, has done its alignment or mapping to that central model, then via that model, you can actually start pushing data from one syntactic model to another without having to do any further alignment, without having to do any further integration. So it's a very, very powerful approach in going forward and being able to link up all of the existing knowledge which is embedded in these syntactic models together into a common, through a common model, okay? And ERA will stay ERA. Rails is their stuff. IATA will do airlines. It's our business. UNCFACT will do the UN stuff, right? This is what they're good at. And so everybody keeps their specialty, but we become interoperable, which is what all of this is about. And with that, I'm going to stop the presentation. Let me just do exactly that. Excuse me, I'm operating too many things at the same time. Okay, no. I'm actually going to invite Michael to join the stage as well. And while I do that, I'm also giving you the stage in order to be able to share your presentation, Michael. So sort of switching hats a bit, I've just presented the semantic stuff. So we've come a long way. We've got an overview what happens in the Federated Project and why we do this. We'll look at the architecture, and then we went more abstract in semantics. And now we're bringing it back to real world stuff. And so Michael will be talking about the living labs that are actually putting all of these things to the test and making it work for real. Michael, I will leave the floor to you.
Thank you very much. Do you see my screen?
Yes, we can see it. Thank you.
Is it pink and says Federated Webinar at the upper?
That's the one. I can see it. Go ahead.
Good. Then I think we are ready to go. So hi again, everybody. Still Michael. Still work for the Swedish Maritime Administration, and I will go through a bit what we are doing within the Federated Project regarding living labs and pilots and stuff like that. So, but before I will tell you anything about our living labs, I would like to, no, apparently not. Yeah. So when we started Federated, the Federated Project some years ago, well, was when we actually still could meet each other face to face, which was very nice at that time. We did identify a lot of different technical things, and we figured out that we needed to tackle them to be able to achieve the ability to connect and share data. So you can see on the screen there was it's a lot of different things. Some are technical, some are not, some are high, some are low, but these were things that we deducted from the partners of the project. This was very unstructured. So before we could start to use them, we needed a way to sort of put them in context. And this is more or less the way we started off with, picking up and putting these words into the world. And this is basically how we see the world, or not the entire world, but at least the world that we are working on. So this picture shows the parties involved in the transport of any given piece of goods. And for you that has really sharp eyes, you notice that air transport mode is missing. This is probably because I'm come from the maritime side, and but I think I can easily solve that by doing that, and then air is also on board. And actually, like Hank was talking about before about semantics, I mean, a port is a port. If it's a vessel or if it's an airplane coming into it, doesn't really matter. Goods will be loaded and discharged. The method might differ, but it's still a port. So what we can see from here that there are many actors involved, and our living labs are actually covering many of these interactions. So what we really was seeking for was a sort of a common ground here. Because if you are going to execute living labs, I mean, you need some sort of a framework to do it within. We didn't have that. And this is a picture of the solution we came up with, and this is actually what Mitch and Hank has described. You have the architecture and you have the semantic model, and then you combine them to actually achieve interoperability, which is great. So I will not go into this model anymore, because I think we have got two really good presentations of them. But what I can say is that these two building blocks is very, very much important for the realization of living labs. I can also tell you a bit about myself and my background. I mean, I do pretty much not exactly the same way things that Hank is doing within on the maritime side. And there we have created a sort of a semantic model for the regulations that IMO, which is the International Maritime Organization, is covering. And we have connected a couple of standards like WCO, UNEC, or UNCFACT, and also ISO. And we on the maritime side also have some special models. So this actually works, and it's a great way to start to communicate. We are communicating maybe within one mode of transport. Makes it a little bit easier, but if you are going to communicate with people from outside your mode of transport, it's not so easy anymore. So having these two building blocks more or less in place is very valid and very important. So where are we right now then? Well, I will fly you quickly through, because there are a lot, so we're not going to any real details here, but we are currently running 21 defined living labs. We do have public and private stakeholders, and they can be on different levels. At least for the public stakeholders, they can be on different levels within a country. Could be the ministry, it could be a public administration like my own, which dealing with maritime, but it can also be a local community which needs to address specific issue for an area. And then we of course also have private stakeholders involved, and they can do domestic transport or cross-border transport. So we do have a lot of business to government interactions, as well as government to business interactions. And then there are some pure business to business transactions going on. Right now, we do have all modes of transport included, which is great, but also a challenge, since we don't always think alike. But I mean, we share the same concerns, and we want the same things. Also, all the partners, as Roland showed you, are spread across Europe, and in some cases also beyond, somewhere else in the world. So this is really great, and we are working quite hard. It's not always easy when we are in this digital format, but slowly we are making progress. So what we are doing is that we are looking into real world problems. We are not inventing problems to solve. We are looking at what is going on. If you for example, if you have an air transport who gets that information, and you use, for example, one record for handling it, then the question is, okay, but the plane has landed, how to get the next, or the correct information to the next mode of transport without, recreating it, punching it in another IT system, or even worse, print the papers and send it on the mail. So this is all about what we have been looking for. It's actually to see where are these pieces of information, where are they shared, or where should they be shared, and how do we do that? One thing which is also always very interesting is getting the estimated time of arrival visible in the transport chain. So that is also something that we are looking into. All modes of transport always, are sort of centered around the estimated time of arrival. So we are addressing these things in the living labs, and as Mitch also mentioned, one of the things that we also want to do is not only have 21 living labs that stands for themselves. That will not benefit much. So we are actually also see how to connect these living labs within each other. Can we have one living lab feeding another living lab, then get some responses back? So again, we do this by using the architecture and the semantics, and the goal is also to validate this and to see if it works in real-world scenarios. We are not there yet, but if you are following and will be following our project, hopefully we will give you that answer in a year or two. I think it's more of a 2 year, but anyway. And this is also what a very nice picture on the right there is trying to show. I mean, the real world in the bottom, the interactions with the semantics and architecture. Then you have the given some given digital services on the top, which you can utilize. So here are some examples. I will not go into this in any details, but for example, we do have a road terminal project to see how you can achieve this. If you disconnect air and maritime, there are also inland ports which sort of handle trucks and trains. So those are looking into that. We have full end-to-end supply chain running in the North Sea, the Baltic corridor between Finland coming into Sweden and moving on to track the movement in real time, and then you can, based on that, see if you can optimize stuff. We do have a EU legislation which we are looking into, which is directed at they call it the FT regulation. It's European Freight Trade Information, and it's about accepting digital document, and this has some connections with the ECMR also, and it's also for easing the burden on mainly today it's mainly focused on road transport, run by Luxembourg. Then we have the IATA living labs, which are about the Internet of Logistics. And I know you all probably, I will not even try to go into that, because I think you know that a lot better than me. But if you don't, Hank is the one to talk to. And then we have a large thing from Spain called Simple, where they are trying to combine stuff from various modes of transport, stemming from train actually. So we do have a good mix, and there are, as you then easily can count, it's 16 more of these ones, and they are all trying to sort of apply this cauliflower you see there, which is our sort of a high-level architecture, a very high level, so to say. And if you do feel an urge to look into this more, please visit the project platform, which you can see on the screen now, and especially, of course, the living labs. And by that, I think I will say thank you and leave it over to Hank, I think.
Thank you very much, Michael. And if I may ask Roland and Mitchell to join again the stage. I did get a few questions, so we have a little bit of time still, about 10-15 minutes. We can discuss those. Welcome back, Roland, and welcome back, Mitchell. So thank you very much, Michael. That really sort of rounded off very nicely from starting at the objectives that Roland sketched out, diving into architecture, diving into semantics, and actually see it coming to life. I've got a few questions, and anybody feel free to respond. But the first one, perhaps, maybe Roland, this one is for you. Could the federated approach be used globally, or is this something that would only work in the EU?
The clear-cut answer is yes. Although we are very special, we are not that special in Europe. So if it works for Europe, it should work for the world. Otherwise, we will be fully disconnected. So yes, please. Whether federated will be the major export product of Europe, I don't know, but we could make we could give it a start. But actually, what we prefer mostly is to also get input from outside Europe in order to tune together, fine-tune together, and seek some cooperation. So, not only for the semantic modeling group or the architecture, we are happy if your feedbacks and feed-ins, and I think the same counts for the living labs. So, no, we're not alone.
We're not alone. Okay, that's good. And perhaps myself, I will add a little bit to that, because we operate on a global basis. And I'm not aware of many areas in the world that face the same challenges the EU does, which is a single economic bloc with many borders, many cultures, many languages, and cultures including on a political sphere and on a business sphere. So I think the challenges that we are dealing with here are, if we can solve them, I'm pretty sure they could be used elsewhere as well, which doesn't mean that other regions will want to. They have their own political agendas, but certainly I think from a solution perspective, I find it hard to believe we'd find that someone else would have problems that we haven't actually counted already within the EU and within this project. So in that sense, I think, yeah, who knows, you know, I think it certainly would be very good. I had another question here, and this one I think is probably for Mitchell. You showed some architectures and some variations. How flexible is that for a company that has already implemented data sharing and already is hosting solutions that are capable of doing the sort of things that Federated is looking at? What would you say to that, Mitchell?
Yeah, so from an architectural point of view, we're deploying as much as we can open standards. So we would like to reuse existing building blocks, and for those challenges that relate to federation of, for example, the index or the registry, we're also looking into open source building blocks to support that, and also considering making interfacing with these objects or architecture building blocks in a general sense available to the public. So I think one of the building blocks is from the DTLF is plug and play, and we're making sure that we have we create a level playing field from the technology point of view as well.
Okay. On one of my slides, I showed some other projects that are going on. You got private sector projects like TradeLens. UNCFACT is very active. You have ERA, which has gone a long way into dealing with some of these challenges as well. How easy do you think it will be for all of us to actually put these things together? Is this a and this is a question to all of you perhaps, but is this a race? Is this a, you know, who's first is going to be setting the standards? What is the philosophy? Because this is not the only show in town, right? It may be an important show, but not the only show in town. Who wants to take that? Mitchell, you want to start? Yes, go ahead.
Yeah, maybe from a technical point of view, that I think that the major players in this field are also developing concepts that are quite comparable to what we are doing, of course. But as mentioned before, that we do not aim to be the nth alternative. We aim to be the connecting project or concept between these ecosystems or platforms. And yeah, the question, how much effort would you need to put in? Well, that's a really hard question. I think concepts are quite comparable. We just need to make sure that we understand each other from within the middle. And actually, from a living lab point of view, we are discovering how would we be able to for example, integrate One Record or TradeLens or any other platform. So we need to be acquainted with these kinds of developments, and we will see how much effort that is. But our aim is basically to make it as effortless as possible.
Okay. And then
I think you also need to figure out actually what do you want to share. What is, I mean, not everything is going to be, I mean, exposed through the federated platform. It might probably it will be a subset which will make it more manageable. I mean, if you look at all the information that required just for entering a country, I mean, you go like, ooh, help me, please. But it's not the entire amount we are after. I mean, it's more to get the right information flowing. What you do need to be able to start up your next transport or your next business step.
I think that's an important point, Michael, and one that I would like to underline. Indeed, that if you take freight from one mode of transport, maritime, and via road, and it goes perhaps a bit by air as well, the actual data that you're sharing is very limited set, because honestly, the people in the air don't really care about how the ship was navigating through the port, right? It's their business. We don't have to know anything about it. And similarly, the road sector doesn't have to know how airlines will deal with disruptions or bad weather or something. Again, it's a different story. So if you look at the actual data sets, and you refer to standards in the IMO, for example, my guess is something like 90% is not relevant for sharing. You know, maybe 10% is, maybe 5% is, but it's a limited set. So I got another question here. This is actually for me. It's is One Record compatible with the Federated Project? Yes. The Internet logistics is what we call the project within the federated environment, mainly because it goes further than just air. You know, it's actually looking at the interaction between other modes of transport as well. And so the Internet logistics is based on One Record. So in that sense, it is fully compatible with federated. And perhaps knowing a bit more about the semantics and working with Mitchell also on the architectural side, we're very much trying from a One Record perspective to stay in line with that, partly by sharing what we know, but also by learning from what is coming out there. And see, for example, you mentioned the things like index and search. You know, these are not things that exist in One Record, so we'll try and make them work. So the longer answer is yes, that's our objective. And that's probably the case for all of the living labs, is they all have their own peculiarities and their own basis. And the challenge that Michael is well aware of is how can you actually make these labs, how do you synchronize them and align them and make sure that they work together? One of the challenges that I have and that Mitchell has is that we're working on a common architecture and a common model whilst we're executing living labs, okay? And so you're you're building the bridge as you walk over it. Maybe that would be something that works in Holland, but it actually be the challenge. You know, we're sort of changing the wheels on the train while it's running, so it's not an easy one. I think I had one more. I think it's linked to the first one. Are living labs limited to the EU? And the question is because maritime and air are often intercontinental, and they're obviously involved here. Michael, I see you're nodding. I see no one shaking their heads, but
no, I mean, IATA is part of it. So I mean, you are not moving only in Europe. So of course, other partners from around the world is welcome, and that would be. I mean, if we could get in one players from somewhere else, that would be very interesting to see if it fits. I also know that Netherlands has things going on with other countries outside the EU.
And from the Air Living Lab, I can confirm that some of our best living labs actually have transport that comes outside the EU into the EU or leaves the EU into other regions, and they're really, for me, they're the really interesting ones, because then we really have sort of the border crossing side, because within the EU, you know, typically the borders are open, but to really deal with those challenges, say e-commerce from China into Europe, is very much part of our discussions.
But I think in particular,
yes, go ahead, Roland. Yeah.
We already engaged in living labs between Finland and Russia, Norway as well. They're both not EU yet. We are engaged in living labs related to China, to Singapore. Always more than happy to further engage into living labs that connecting outside or to third countries. Please do.
Good. I see it's nearly 3:30. I wonder if there's just time for a quick round, just to perhaps some last comments from the panel, perhaps on where they see the project go. If you have any messages for the people participating in the webinar, most of them will be from the aviation side, but not all. I've seen some people that are cross-modal as well. So maybe a quick round. Mitchell, let's start with you. Any last thoughts or comments on Federated?
Yeah, so I think the most important thing is that we've developed with very smart people and a differentiating group the concept until now, and I think that testing these from within the living labs and learning from that will be the most challenging for the coming period. So I'm very much looking forward to that, to validate the architecture and to refine in such a sense that it will be available to a broad audience within Europe. So yeah, that's something I'm looking forward to.
Thank you, Mitchell. Michael, any last thoughts?
Actually, I would probably echo what Mitchell has said, but I also think that I think the current thing we are facing right now is actually getting the people together and start to construct and start to test, which is a bit of a challenge. And I think sometimes we have to be honest with that, especially because of the situation in the world with Corona and stuff. But I think we are learning how to deal with these tools and stuff, and then I think we can do something. But as Mitch said, the most important thing is to validate what we have been doing. To see if it works in the real world.
I agree with you that's the really is making it work. What makes it interesting for me too is it's one thing designing. Design is easy, I would say, but actually making it work is a very different ballgame. Roland, I will leave the last thoughts to you.
Thank you. Well, in addition to what has been said, I think the proof of the pudding is in the eating, and the eating relates to not only living labs, it also relates to consultation, to make our message clearer, to interact on our message, and to adjust to different kind of logistic chain operators. And that is one of the major issues, and that is not so very much stressed in this presentation yet, but one of our major activities also is consultation, how to deal with the different people, local and global. And in our perspective, it's a bit more local. And this concept of federated, if you start getting to know it, it is fascinating. But before you get there, it takes some while. And we want to bring that closer to as soon as you get a knowledge about it, it's like, you want to be part of it, want to take place. And in that sense, we are in a transition period where everybody needs not only us as an enabler, but also the competences to do data sharing. And that is still a big challenge ahead. And there we need all the efforts and participation of possible partners or non-partners, but possible collaborators. So join us. Thanks.
Okay, join us. I think that's a good way to leave this. Also a good way to remind you that there's one more webinar next Tuesday. It's on actual tools and products that we have developed around digital cargo, one record and other things, and our colleagues from the products team will be presenting that. So for those of you that are here, by all means join us next Tuesday, same time, same process. And with that, I will close the webinar in thanking Michael, Mitchell, and Roland very much for participating in this, and look forward to providing an update in a near future to all of you. So thank you very much.
Thank you.
Thank you.
Pleasure. Bye. Thank you.